Welcome back, everybody. Mr. Renneker here, and in today's lesson, we are going to talk about circles in the real world. So we're going to be looking at some application-style problems. Our objectives in this lesson are going to be to apply the concepts we've learned already about circumference and area to solve real-world problems. We're going to go ahead and jump right into it. In our first example, we're going to be estimating a diameter. The problem says that the circumference of the roll of caution tape decreases 10.5 inches after a construction worker uses some of the tape. Which of the following is the best estimate of the diameter of the roll after the decrease? So looking at the picture, I see that they give us a current circumference of 31.4 inches. And the problem, as I reread it, says that the circumference of the roll of caution tape has decreased or went down 10.5 inches. So even though the picture states that the circumference is 31.4 inches, that has now changed and went down by 10.5 inches, making the current circumference that I'm concerned about 20.9 inches. Now what they're actually asking me to do is estimate basically what the diameter, or the distance across the center of that roll of tape is. What should roughly that dimension be after this decrease has happened? So we're going to use that new circumference and think about, well, what do we know about a relationship between circumference and diameter that they're asking me to find? Well, in earlier lessons, what we learned is that one of the ways we could find circumference is to take pi times that circle's diameter. Pi times diameter is one of the most straightforward definitions we have for circumference, and again, they do relate circumference and diameter to each other. So we're going to use that to help us get started. What we can do here is substitute in the information we know, and then use some algebraic skills to work backwards for the information we would like to know. Again, we know that the new circumference right now is 20.9 inches. We already have some good values for pi, for example, 3.14. And we know that if we multiplied that by diameter, we'd find the circumference. Of course, the difference in this situation is that normally we would take pi times diameter to find circumference. But we already know circumference, so we're going to work backwards and solve by dividing by pi on both sides to help us estimate that diameter that we really want to know. Of course, on the right-hand side, pi divided by itself is 1. We're left with 1d, or the diameter, which is great. That's what we want to know. On the other side, we would have to grab a calculator to solve for 20.9 divided by 3.14. And there are a variety of different ways we could estimate with this problem, but if you were to just use a calculator, you will get a pretty lengthy decimal, but it should be fairly close to about 6.65, again, without doing any extra rounding. So going back to the problem, it says, what's the best estimate of the diameter of the roll? And our options are 5 inches, 7 inches, 10, or 12 inches. And looking at our estimate, which is 6.65, it would appear here that answer B, 7 inches, is closest to that. So in this problem, we were able to use what we knew about circumference and apply it to a situation that actually allows us to solve for a missing diameter. Let's take a look at one more example. In this final example, we have a situation with some lighthouses, and it says the Hillsborough Inlet Lighthouse lights up how much more area than the Jupiter Inlet Lighthouse. So we can see our two lighthouses here on our image. They appear to be down in Florida. And as I reread through the problem carefully, I notice that they're asking me to do something with their areas. So before I get too far in depth, I think it might be helpful to actually calculate those areas. So I'm going to find the area of the Jupiter Lighthouse, and then I'm also going to find the area of the Hillsborough Lighthouse and see where we end up. Now, we already know from the past that area can be found by taking pi times the radius of a given circle squared. We're going to do that for both of these here. For the Jupiter Inlet Lighthouse, I see that the radius here is 18 miles. So we're going to take pi times 18 squared. For the Hillsborough Inlet House, I see the radius is 28 miles. So we are going to take pi times 28 squared. And now for the calculations. In both scenarios, well, let's see. Actually, the first one, I think I'm going to use 3.14 for pi times 18 squared, which is 324. And with a calculator, I find that first area to be 1,017.36 square miles. That's about how much space that lighthouse can actually light up. For the next lighthouse, I'll start with the same idea, but this time I am going to use 22/7 for pi because I noticed that that radius they gave us is divisible by 7, so I think that might leave us with a cleaner answer. And for 28 squared, I get 784, which I'll multiply by 22/7, and I get about 2,464 square miles. So far what I have is the actual area of the amount of space that each lighthouse can illuminate. But what the question actually asked us as I reread here is how much more area does one lighthouse light up than the other? When I see a phrase like how much more, I actually know that I'm trying to find the difference between those two amounts. So we're actually going to have to subtract the two areas. So I'll need to do some subtraction like this. Although, again, ladies and gentlemen, I would highly recommend you guys make use of a calculator here. When I subtract 2,464 minus 1,017.36, I get 1,446.64, and of course that would be in square miles. Now you will see very similar problems to both of these examples that we've seen here on your assignment. Be a little bit flexible with the versions of pi that you use, meaning whether you use 3.14 or 22/7, as your practice is going to either ask you to do both or it's going to leave you to make those decisions, and you might have to try more than one depending on the scenario. So just make sure you guys are ready for that. This assignment may take a little extra patience and a little extra work and creativity on your part, so be ready for that. As always, good luck, and I'll see you next time.